Friction is the next force that we'll see in a course like this. And friction is definitely a rubbing force. It comes when two objects get in contact with each other and they start rubbing into each other. Again, an example I'll sort of put up for you here is an object just sitting on a surface. Now, if you sort of got this interaction between the surface, say the bottom of this block here and the top of the table, and magnified it here, what you'd see is the bottom of the block here would be really rough like this, and the surface here would be really rough also. So this is the block sitting on the surface like that, really rough like that. Why is that? Because this is just a very microscopic view. Nothing is completely smooth, and, well, blocks and tables that look smooth really aren't microscopically. And so what happens then is when you get these rough surfaces sort of grinding past each other, you can see that like where this sharp thing goes in this valley right here, this one here, all these little edges touching in here, if you tried to pull the block, say, this way, that would be the equivalent to try to pull this thing this way. You'd see you have all this jaggedness here trying to rub over all this other jaggedness. The jaggedness of the bottom of the block would try to rub over the jaggedness of the surface of the table here, and that presents kind of a problem. It is not a free-flowing example. It just doesn't go nice and easily like that, and that's the nature of the frictional force. Like if you try to pull on the block this way with a force F like that to try to get these rough surfaces to drag over each other, it's going to be a bit resistive. It won't just go automatically and easily by itself, and so it's almost like there's a force going this way. That's called the frictional force, and I'll just write a script F like that. So there's a couple things to know about friction. One, it always opposes motion. Now, that's not to say it just opposes any pull you pull on it, because we know the motion of an object is more denoted by its v vector. So friction always opposes the direction the object's moving on, which is given by its instantaneous velocity vector, not necessarily a force here. So it always opposes motion. Number two, the definition of friction here is equal to mu times the normal force. So this is just the good old normal force, and there's another video on that which has to do with objects sitting on surfaces here. But now there's another parameter called mu, and it's called the coefficient of friction. So it looks like a U with a long tail on it here. Coefficient of friction. That's what it's called. So I'd encourage you to either look in the index of your book to read about that, or look at it in Wikipedia, search for it in Wikipedia. But what the coefficient of friction is about what two objects are actually rubbing here. So if you go back to this example over here, you have this microscopic roughness. Well, what were the two objects? Was it a plastic coffee cup on a table? Or was it a rubber tire on concrete? Or was it your rubber-soled tennis shoe on a linoleum floor? The coefficient of friction has to do with what two objects are rubbing. So again, if you look in your book on Wikipedia, often you'll see charts of coefficients of friction. The charts will sort of say, well, what two objects are rubbing? Here's what mu you should use for it here. This symbol here is the Greek letter mu, mu. So that's why you say it. It's not u, it's mu. Values of coefficient of friction that we'll deal with in this class are things like 0.15, 0.2, 0.4, all the way up to maybe 0.8 or 0.9. And as you might guess, the lower the coefficient of friction, the more slippery the contact will be. So 0.15 might be like your shoe on a ice skating rink on ice, where 0.95 might be a rubber tire on dry concrete. So the mu definitely has to do with the strength of the friction, or maybe 0.2 or 0.4 might be a couple pieces of wood sliding past each other. So you look up in charts there to see what two objects you're sliding, and that'll give you an indication of what the coefficient of friction will be. So that's the nature of the force. Anytime there's friction involved, you must always draw a force on an object that opposes motion. Here's where the magnitude comes from, mu times the normal force. So you have to be able to find and recognize the normal force on an object, multiply it by a mu, often it's given, or you can look it up in a table or whatnot, and that gives you the magnitude of the frictional force in newtons.